Welcome to the Z-Hut's Mad Scientist Laboratory. I'm Professor Z, and today we're going to attempt to take over the world using Arduinos. Grab your favorite Arduino board and put on your tinfoil hat, because it's time to build. Today, we will be trying to take over the world by building this ultrasonic tripwire alarm. Now, this alarm has a maximum distance sensitivity adjustment, which means you can set this in a hallway, and where normally it would be instead of picking up the wall, you can adjust the potentiometer on the side for a maximum distance that will set this off. When we get to the Arduino code itself, I will show you how you can change that. I have mine set for about 3 feet because I use it on my counters to deter my cats. They like to get into everything. But this can be set for a greater range, and when we get to the Arduino code, we will go into that. The enclosure itself is very easy and inexpensive to build. It is 2.5 inches of 4-inch PVC plumbing pipe, and 2 end caps. If you ask for them by name, tell them you want 4-inch test caps. And you want the ones, they make 2 different styles. They make ones that fit on the inside that are knockout test caps, and then they have the fit over test caps, and you want the ones that fit over the pipe, not the ones that go in. For cutting the hole for the speaker, and I do recommend using the largest speaker that will fit in here, and I'm using a 3.5 inch speaker. I would try to use a 3 to 3.5. Unfortunately, a 4 will not fit. You can get a hole saw at your local unclaimed freight or stores like Northern Tool or Harbor Freight. You can get a hole saw very inexpensively, and you can even get a set of hole saws for under $10, generally inexpensive ones, and they work great for cutting holes in the plastic. Now, for the construction of the actual alarm, I'm going to go ahead and remove the speaker. So we are using a HC-SR04 ultrasonic sensor. These are very inexpensive. You can find them on eBay and other places for under $2 shipped. And that's if you're willing to wait, 2 weeks to get it. If you're in the US like I am and you order one from here that you would receive within like 3 to 4 days, you are going to pay more. I order my stuff ahead of time before I build the projects, and I order in bulk, so I get a good price, and I keep the stuff on hand. But yet, in the enclosure, you just measure. And the best way to measure, now these are going to be very similar, but these are made by multiple different manufacturers, so there might be slight differences. Measure from the outside of one of the sensor to the inside of the other, and I have about 1 1/8 inches apart. And that will tell you what the center to center is by measuring from the outside of the one to the inside of the other. Then also, when you're considering how to drill the holes, make sure that you have enough room for the header pins to fit and still be able to get your jumper wires on. And then to attach it, I simply used a little bit of hot glue in all 4 corners. The drill bit size, that's just a little over a 1/2 inch. Like I said, manufacturers, they're going to be slight differences depending on the manufacturer. So just use the corresponding drill bit. Use about as close to the size as you can get. The other parts we will need, of course, an Arduino, and I'm using a Nano. And we're going to need a potentiometer. The value does not really matter. This one I do believe was a 5K, but the value will not matter for this application. Anything 5K, 10K, 100K, 1 meg, any of them will work. It is secured by hot glue because of the thickness of the pipe. The one I used, one that I had on hand. If you have to order one, I would find one in the wall. On this, you want to make sure it's a 1/4 inch thick, so you want the threaded section to be more than a 1/4 inch so you get the nut on. Otherwise, if you do like I did, I just hot glue gunned it in there, it will stay. Other parts we will need is a TIP 120 Darlington transistor, and that is used to amplify the speaker, the tones that we were using for the alarm, because by doing it this way, the alarm is much louder, and I will demonstrate this working here in a few moments. You can use something similar to that if you don't have a TIP 120 and you're trying to use what you have on hand, but I do recommend using a Darlington. It amplifies it way better. Now, I haven't soldered this together yet, so I used a breadboard and jumper wires, which you will also need. But if you're going to be making this permanent, and that is something I will be doing shortly, I will be soldering everything together. So if that's the case, you will want a regular point-to-point solder board that you can solder this together on. The only other part we will need is a power jack that corresponds to whatever power supply you're using. I'm using a wall wart, and here's the plug. The other end is plugged into an extension cord. Well, I can grab it. Most people refer to these as wall warts, but it's just a AC to DC power supply. I recommend 9 volts. That seems to work fine with these between 2-inch and 3.5-inch speakers. It won't blow them out by amplifying it with the TIP 120. You can try 12 volts on this, but be careful. You could possibly blow your speaker out. And I do not recommend anything under 9. You could get away with 6 or 7 volts if that's all you have, but it's not going to be as loud. All right, I'm going to connect the speaker back up, and I'll demonstrate this working. And then what we will do is we will go over to the computer and take a look at the code. So one side goes to the TIP 120 transistor. The other side of the speaker goes to positive, because we are using the transistor to bring through ground for the amplification. I'll put this back on. I do believe that is all the way to the minimum. Oh, I had the potentiometer turned the wrong way. There is a computer monitor about 2.5 feet just off the screen, and if I turn the potentiometer, eventually the range will extend enough to where it picks the monitor up, and that's why we have the potentiometer. So if you're using this in a hallway that's only 2-3 feet wide, you can set the potentiometer. What you do is you put it where you want it, and then turn the potentiometer till the alarm quits going off, and then when something comes in front of it, it goes off. I have mine set. I do believe it's a 6. It'll come down to 6 inches, and that's the minimum distance. So anything from the 6 inches back will set it off. And I do believe I have this set at 3 feet for the maximum, because my main use for this is putting it on the countertops, because I have 3 indoor cats and they like to get into everything, and I don't really mind them jumping on, tables and stuff, except my kitchen table and my kitchen counter. I don't want a cat that just came out of the litter box going up and walking his dirty, pooped up paws on my counter. So that's why I built this, but this could be used for many applications. Is the tripwire alarm. You could run it off of batteries as well, but I do recommend the wall wart because batteries, this will only last so long. All right. I think we've went over everything on the construction. Another thing I haven't put on here yet, but I have some little rubber feet that I picked up at a local unclaimed freight store. They're just little peel and stick rubber feet. I will be putting them on there. I just haven't gotten around to it yet. That's an option. I do believe I've gone over everything on the construction, so why don't we go over to the computer and I'll go through the I'll show you a close-up. That's the inside there, but what we're going to do is go over to the computer and go over the circuit diagram of how this is assembled, and it's pretty easy. Then we'll go and we'll take a quick run through the Arduino code. I'm going to primarily just go into how to change the parts for setting the maximum and minimum distance. There's not really anything else you're going to want to change on this or it will not function properly, but we'll go over that part of it. So all right, I will fire up the computer and we'll get to the code in just a second. So as you can see, this circuit is fairly simple to put together, which also makes this a very good beginner's project. So let's just start with the HC SR04 ultrasonic sensor. We're supplying it with 5 volts from our Arduino Nano. The echo pin goes to digital pin 10. The trigger pin goes to digital pin 9. Now you can change the pins. It's just in the sketch you have to change it as well. But I don't really see any reason unless you want to start changing the sketch and stuff around. I would just put it to pin 10 and 9. Of course our ground goes to our common ground. Next we have our speaker here, and we're pulling the positive side right off our 9 volt input. Goes to the positive, then the negative side goes to our TIP 120, and then the output goes to our common ground, and the base goes to digital pin 3. Once again, you can change what pin you put this on. Just make sure you change that in the Arduino sketch as well. All right, then lastly, we have our potentiometer, and we just have the wiper, which is generally the middle pin. Not always. I've run into some potentiometers that the middle pin is not always the wiper, but mostly they are. We're running this to analog pin 1, and then we're hooking one side to our positive 5 volts and the other side to our common ground. When you turn the potentiometer, if you're turning it to the right and it's going, the distance is increasing but you want it to decrease instead, basically if it's backwards to what you would want, just switch the positive and negative, these two on the potentiometer. Leave the wiper to the A1, just switch the positive and negative, and that will reverse it, and then it will be going in the direction you want. All right, then finally, of course, we have our Arduino Nano in the middle here. That is all there is to putting this together. And like I said, this is a fairly easy project to build. So all right, let's go over to the Arduino code. Okay, To get a copy of this code, look in the description below and you'll find a link to this project's web page, and you will be able to go there and copy this and paste it in your Arduino IDE. You will also find a copy of the schematic that we just looked at, and you'll also find a parts list and places, sources where you can get these items if you don't have them. All right, like I said, most of this you do not want to change anything. If you change the trigger pin, echo pin, you just change it here. If you change the analog pin for the potentiometer, change it here. Otherwise, let's just go down, and what we're doing is we're just mapping that potentiometer, and we're taking the value of 0 to 1023 and mapping that to 6 inches to 36 inches. If you want the minimum to be less than 6 inches, like 3 inches, change that to 3. If you want it to be more, maybe you want to set yours to be like 12 inches is the minimum distance. And maybe you want to put this 48 inches as the maximum distance. The smaller the range between these two numbers, the more precise the potentiometer will be. But you can go, 6 inches to the maximum on this. Trying to remember, I think like 15 feet or 10 feet or 15 feet. If I do believe after that it starts kind of not working very well. I'd have to look at the data sheet itself. I can't remember offhand. Like I said, I'm using mine on a counter, so 36 works fine. But yeah, you can put this up to 48 or even higher. Just go ahead and play with that. Just don't change the 0 and 1023. That's just the value of the potentiometer. 0 means it's all the way down, and 120 or 1023 means it's all the way up. The only other thing, if you want to do this in metric instead of inches, if you want metric, just take uncomment this line out, so get rid of those two lines right there, and then comment this line out. So you'd go like that, and then you would uncomment that line out, and now you would be in metric. So remember, if you're running metric, then this would be 6 centimeters to 36 centimeters. So you would want to change this to correspond to how many centimeters you want the range to be. And by default, if you copy this off of the website, it will be in inches, like that. So, all right. The only other thing, if you wanted to play around with the alarm that goes off, you could try changing the tones. I'm using a 500 and 300. You could try playing with that, or maybe you just want a constant tone. Maybe you want to have a 3-tone alarm instead of just the 2. You could play with this as well, but otherwise, all of this in here, you do not want to mess with anything with the digital writing, the trigger pins, highs and lows, and reading that, the echo pin. You don't want to mess with any of that, or this will not work at all. All right. And as you can see, there is no library needed for this, so you don't have to download anything. So with that, we will wrap this up. I wish you luck on taking over the world by building this ultrasonic alarm. And remember, and this is very, very, very important, to always wear your tinfoil hat, because we do not want the government and the men in black to know what we're up to.